this lecture, we are going to learn about the measures of central tendency. In statistics, measures of central tendency are statistical measures that represent the central or typical value of a data set. They provide information about the center or average of the data distribution. The three commonly used measures of central tendency are mean, median, and mode. Number one, mean. Mean is also known as the average, and it is calculated by summing all the values in a data set and dividing by the total number of values. It is sensitive to extreme values and provides a measure of the overall typical value. The formula is on your screen. Number two, median. The median is the middle value in a data set when it is sorted in ascending or descending order. If the data set has an odd number of values, the median is the middle value. And if the number is even, then the median is the average of the two middle values. The median is less influenced by extreme values compared to the mean and provides a measure of the middle value. To calculate the median, the data must be ordered first. Number three, mode. Mode is the value that occurs most frequently in a data set. It represents the values with the highest frequency or occurrence. A data set may have one mode, that is unimodal, two modes, bimodal, or more than two modes, that is multimodal. In some cases, there may be no mode if no value is repeated. The mode is useful for identifying the most common values in a data set. These measures of central tendency are used to describe the distribution and summarize the data. They provide insights into the typical value and help in understanding the central characteristics of a data set. Now, it is important to consider the appropriate measure of central tendency based on the data type, distribution, and the purpose of analysis. Let's take an example on how we can measure the central tendency of a data in Python. This time also, we are going to use the same employee dataset. We are going to find out the central tendency of the monthly income column from the employee dataset. But before that, let us check out the minimum and maximum values present in the monthly income column. We are going to use the max and min functions respectively to find out the maximum and minimum values present inside the monthly income column. After we execute this block of code, you can see that the maximum value in this column is 19,999 and the minimum value is 1,009. The first line calculates the mean, that is average, of the monthly income column in the data frame df and assigns it to the variable mean salary. The mean is computed by summing up all the values in the monthly income column and dividing it by the total number of values. The second line calculates the median of the monthly income column in the data frame df and assigns it to the variable median salary. The median is the middle value when the monthly income values are sorted in ascending or descending order. It represents the value below which half of the values fall and above which half of the values fall. The third line calculates the mode of the monthly income column in the data frame df and assigns it to the variable mode salary. The mode represents the most frequently occurring values in the monthly income column. The mode function returns the mode and the values attribute extracts the mode value as an array. Overall, this code calculates and displays the mean, median, and mode of the monthly income column in the df data frame, providing insights into the central tendency of salary distribution in the dataset. If you look at the results, there is a huge difference between the mean salary and median salary, which definitely means that something is off. Let us try to understand the reason. If the value of mean is greater than the median, it suggests that the distribution of the data is positively skewed or right-skewed. In a positively skewed distribution, the tail of the distribution extends towards higher values, pulling the mean towards the higher end. Now, here is a simple explanation. If the mean is greater than the median, this indicates that the data set has some larger values that are pulling the average mean towards the higher end of the distribution. It suggests that there are a few relatively high income values that are impacting the overall average. If the median is greater than the mean, this indicates that the data set has some smaller values that are pulling the median towards the lower end of the distribution. It suggests that there are a few relatively low income values that are impacting the overall median. In summary, when the mean is greater than the median, it implies that the distribution is skewed towards higher values. However, it is important to consider the context and the nature of the data to draw meaningful conclusions about the distribution and its implications. And with this, we have reached the end.